All right, welcome back to 9.6. We're going to do this example with a 3 by 3 matrix. But before we do that, I wanted to mention that if you have a situation where you end up with one row that's all zeros, like you're working along your Gaussian elimination, and you end up with a row of all zeros, that's going to be a situation where you have infinitely many solutions. So that's a situation where, right, if you were doing this by hand, you would have multiplied this one by 2 and then gotten 0 plus 0 equals 0 after you added them together, multiplied by -2. And so that would have been clear to you, hopefully, that was infinitely many solutions. So it's the same idea. If you end up with a row that's all zeros, end up with a row that's all zeros, that's going to be infinitely many solutions. Okay, let's look at a 3 by 3 example. So here we have our three equations, 3 unknowns, augmented matrix, and we want to get row echelon form so that we can solve this. And then at that point, I'm even going to continue into reduced row echelon form so that we actually have our solution. So the first thing you want to do is you want to get a 1 here. There's already a 1 here, so we can skip that step. But usually that would just require dividing this row by whatever that happens to be. And then we want to get a 0 here. So we're going to multiply the top row by -2, add it to the second row, and then put that in the second row. So that's what this says here. We're going to multiply the first row by -2, add it to the second row, and then put it in the second row. So we would get -2 plus 2 is 0. Positive 6 plus 5 is 1. -8 plus 6 is -2. -6 plus 6 is 0. So that's how they got this row. And now we want to also get a 0 here. So we're going to do the same thing. We're going to multiply the top row by 3, add it to the third row, and put it in the third row. So multiply the top row by 3, add it to the third row, put it in the third row to get this 0, right? So we're just getting the top row to match equal but opposite with the one we're trying to get rid of, adding them together and putting that in the row that we want, which in this case is the third row. And then we're going to get this 1 here to be a 1. It's already a 1, so we don't have to do that. But again, we would have just divided this whole row by whatever this number was in order to get it to be a 1. Then we want to get this to be a 0. So remember, we're making that diagonal of 1s, and we want all of the things below it to be 0s. So we're going to get this to be a 0. So we're going to multiply this row by 6, because then we don't have to worry about these because these are just going to be 0. So we're going to get this row by 6. You always want to do multiply the row that's going to give you the least amount of work. So if I multiplied this row by 2, that would get rid of this 0, but it would introduce a number back in this 0. So it would make this 0 if I multiply this by 2, but it would introduce a number back here, which is not what I want. So I want to use the row that already has a 0 here, right? So then no matter what I multiply this by, I'm not going to accidentally introduce a number back here. So I want to use this row. Basically, I want to use the lowest row that I've already made the 1 in. Hopefully that makes sense. And so I'm going to make this 0. I'm going to make this 0. So I want to multiply this row by 6, add the rows together, and that will make this 0. So multiply row 2 by 6, add it to row 3, and put it in row 3, and that will give you this row. Then I want to get this to be 1. I want to get this to be 1, and so I want to divide this whole row by 4. I want to divide this whole row by 4. So I'm not sure why they're dividing by 2. That doesn't make sense to me. Because we would want to divide this by 4 in order to get this to be 1. So I think the book made a mistake here. I think this is supposed to be dividing by 4, and then we get a 1 here, and we get 15 over 4 here. So our z, I'm just going to write that, what this is supposed to be. So this should be 1 after we've divided by 4. So I'm actually going to write it down here. So we're going to divide, instead of dividing by 2, we're going to divide by 4. And over here, we're going to get 15 over 4. I have no idea where 21 over 2 came from. That doesn't make a whole lot of sense. So our reduced row echelon form is going to be 1, 0, 0, negative 3, 1, 0, 4, negative 2, 1, and then 3, negative 6, 15 over 4. All right. So now I want to get, so this is our echelon form. I want to get reduced echelon form. So I want to get all of these to be zeros as well. That's going to be my goal. So at this point, you could stop, turn this back into equations, and substitute. But I'm going to go ahead and show how we're going to get this section to be 0. So the first thing we're going to get to be 0 is this one. So we're going to have to multiply this row by 3. So remember, I can't multiply this row because this would just be 0. So that wouldn't make any sense. So I'm going to multiply this row by 3. I'm going to write that above. I'm going to write that above so you can see what that would be. So it'd be 0, 3, negative 6, negative 12. Nope, negative 18. What am I thinking? I don't know. Negative 18. All right, so multiplying this row by 3, and then we're going to add it to the top row, and we're going to put that in the top row. So we're going to get 1, 0, negative 2, negative 15. 0, 1, negative 2, negative 6, 0, 0, 1, 15 over 4. All right. So now the next thing I want to do is I want to get this to be a 0. I want to get this to be a 0. And you might think, oh, well, let's just subtract these 2 rows. But then I would be introducing this number back in here. So I want to multiply this row by 2 and add the top row with the bottom row so that I don't introduce a new number because I just want to change this number. So we're going to multiply the bottom by 2. And then we're going to add the top and the bottom, and we're going to put it in the top row. So if I multiply this by 2, I'm going to get 2 and 15 over 2. And then I'm going to add. So my new top row is going to be 1, 0, 0. And then negative 15 plus 15 over 2 is negative 30 over 2 plus 15 over 2. So that's negative 15 over 2. And then 0, 1, negative 2, negative 6, 0, 0, 1, and 15 over 4. So we finished with the top row, right? Now this essentially reads x equals negative 15 over 2. X equals negative 15 over 2. That's what this reads. So the last thing we need to do is we need to get this to be 0. So we're going to multiply this again by 2 and just add. So I already have what that is down here. So I'm going to get in my middle row now. So I'm going to multiply this by 2 and add, and I'm going to put them in the middle row because that's the row that I want to change. It's 0, 1, 0. And then negative 6 plus 15 over 2. So that's negative 12 over 2 plus 15 over 2 is 3 over 2. And then the rest of my rows are the same. So my solution, once I'm done writing all of this, okay, not the best, but you know what I'm trying to say. My solution is going to be negative 15 over 2, 3 over 2, and 15 over 4. So that's going to be my final solution, x, y, and z, corresponding with x, y, and z. All right, so this is reduced row echelon form. And in this form, we can just read the solutions off of the side. All right, hopefully that helps, and I will see you in the next video.